Hello everyone. In this tutorial, we are discussing about some other deep learning, advanced deep learning concepts and techniques. So, the some of the advanced techniques like and concepts like GANs. So, what is GANs, right? So, what is at first we need to know the what is GAN. So, GANs uh, basically GANs are the models that learn to create a new data like images by computing. One part tries to make fake data look real, while another tries to tell real from fake. This back and forth process leads to better and better fake data. So types of so what are the types of GAN? There is the vanilla GAN. This is basically this is the simplest type of GAN, and basically here at the generator and the discriminator are simple basic multi-layer perceptrons. In vanilla GAN, the algorithm is really simple. It basically tries to optimize the mathematical equation using stochastic gradient descent. And conditional GAN, CGAN basically can be described as a deep learning method, which is in which some conditional parameters are put into place. In CGAN, basically an additional parameter y is added to the generator for generating the corresponding data. Labels are also put into the input to the discriminator in order for the discriminator to help distinguish real data from the fake generated data. And deep learning, basically DGAN, DCGAN, basically that is the one of the most popular and also the most successful implementations of GAN. Basically, it is composed of convnates, that is convolutional neural networks, that is in place of multi-layer perceptrons. So the convnates are implemented without max pooling, which is in fact replaced by the convolution stride, and also the layers are not fully connected. And after that, the Laplacian parameter, basically Laplacian pyramidite GAN. Basically, the Laplacian pyramid GAN, it is a linear invertible image representation consisting of a set of band pass images and space and octave apart. So, plus a low frequency residual. So basically, this approach uses multiple numbers of generator and discriminator networks and different levels of Laplacian parameter. And this approach is mainly used by the it produces very high quality images. The image is downsampled at first at each layer of the pyramid, and then it is again upscaled at each layer in the backward pass, and where the image acquires some noise from the conditional GAN, and these layers until it reaches its original size. And at last, the SR GAN, that is the super resolution GAN. So as its name suggests, is the basically it designs a GAN in which a deep neural network basically used along with an basically an adversarial network in order to produce high resolution image. So this type of GAN is particularly useful in optimally upscaling native low resolution images to enhance their details, minimizing errors while doing so. And after that, we basically we have to understand, and we have to hands on doing by implementation of some GAN application. So at first, as we saw before in every videos, that we importing the necessary libraries or dependencies, and after that we basically define a basic transformation, that is the yeah basically after that we basically define a basic transformation. Basically, this code is creating a set of infrastructure for pre-processing images before feeding them into a neural network. So what this line of code or this chunk of code, what it does, basically transform dot to tensor. It basically, this part converts an image into a format that the computer can understand. It also changes the pixel values from numbers between 0 to 255 to numbers between 0 to 1. basically computers understand 0 to 0 and 1, and we have to put the numbers into between that. And transform the dot normalize, that basically this step basically adjusts the pixel values further. It basically subtracts zero point 0.5 from each pixel value and then divides by zero point 0.5. So this helps the neural network learn better by making the image data into more consistent way. And after that, the we basically have to train and test our data. So the dataset is our CIF AR10. Basically, this dataset basically doing the this line loads the CIFAR 10 dataset, which is a popular dataset of images for computer vision tasks. And after that, with this root uh, this line basically root equal to this slash data. This line basically defines where to load, download, and store the dataset. And after that, train equal to true means we are loading the training data, that is images and levels. And download equal to true means this downloads the dataset if it's not already present in the specified location. And transform equal to transform means we apply the image processing steps defined earlier using the transformation variable. And after that, we creating a downloader, right? So I mean, sorry, not downloader, data loader. So data loader, basically this line creates a special data iterator called a data loader. It helps us manages and accesses the training data efficiently. And the train underscore dataset, this tells the data loader which dataset to use. And after that, this specifies after that, this line batch size equal to 32, this specifies how many images we want to process at once. And shuffle equal to true means this shuffle the order of the images in a dataset during training. So in simple terms, we are fetching a bunch of training images and getting them ready for our neural network by applying the transformation we defined earlier. And after that, this chunk of code basically basically setting up some important values called hyperparameters. And for training a machine learning model, think of hyperparameters are the settings, or I mean the knobs of the knobs that we adjust to influence how the model learns. And after that, we basically creating a class that is generator. And this generator class basically this code basically defines a generator model. And a crucial part of the this part is the most crucial part of the any GAN problem. So its job is basically create a new fake images. So how does it work, right? How does it work? So basically, we give input. It starts it starts with a random noise vector, which is a list of random numbers. And we basically process it. After that, we get our, yeah. So at first, we basically create a model that is generator. And that is we use here the ReLU layer. So yeah. So this generator takes this random noise, passes it through the series of layers, gradually building an image. And linear layers, this convert the random noise into a larger set of numbers. ReLU, this function basically introduces non-linearity, helping the model learn complex patterns. And unflattened reshape the data into a 3D structure similar to an image. Upsample doubles the size of the image. Convolution 2D, conv 2D basically applies filters to the image to extract features. Batch normal 2D normalizes the data to improve training. 10H basically scales the output pixel values to be between -1 and 1. And in basically in simpler terms, this basically imagine a generator as an artist. It starts with a random noise and gradually builds a picture using some different brushes and colors and all of stuff all and I mean, in real life, just we think about the real life scenario, right? Real life and an artist. So basically, his goal is to create a picture that looks like so real, and that it can fool someone into, not fool someone, basically look some I mean look very close but not real. So it can basically fill someone that into thinking that it's a real image, right? So that's a part. And after that, this chunk of code basically takes the input, and similarly the conv2d basically it applies, filters the extract images from the image. Likirelu basically introduces non-linearity. Dropout randomly basically drops out the neurons to prevent overfitting. And batch normal 2d basically normalizes the data into improve training. Flatten, basically we have to understand the flatten part. So it converts the image into a flat vector. And after that we fully connected the layer to produce a single output value. And sigmoid activation function uses here to squashes the output to a probability between 0 and 1. So output, basically the output is a number between 0 and 1, so representing the probability of the input image is real. And so basically in simpler terms, imagine a discriminator as a detective. So it examines an image and decides if it's real or fake. So it looks for clues that in the image, that I mean the features in the image, so to make its decision, right? So yeah. And after that we basically create an object, so generator discriminator. And we basically use here the optimizers, that is the creating an optimizer. And this line optimizer underscore g, this line basically creates an or adam optimizer for the generator with specified learning rate and beta values. And and the next line creates an adam optimizer for the discriminator with the same settings. And after that, the training loop, in this training loop we basically I mean in this training loop, this loop iterates through the entire training data multiple times. This loop iterates through batches of images provided by the data loader. And training the discriminator, I mean the art critic, so resets the gradients for the discriminator before updating the weights. And z equal to torch, I mean this thing, yeah, z equal to torch dot, this line basically generates random noise as an input for the generator. And after that we creates fake images using the generator and calculates the discriminator loss for both real and fake images. So real, I mean the real loss means how well did the discriminator identify real images as well, and fake loss means how well did the discriminator identify fake images as fake. So d underscore loss, this line combines real and fake loss for a combined discriminator loss, and after that computes the gradients at the discriminator based on the loss. So the training part, the generator part, basically it basically resets the gradients of the generator before resets the generator before updating its weights. And creates a fake images using the generator with some random noise, and calculates then generator's loss. This is how well the generator fooled the discriminator into thinking its images are real. And after that updates the generators weights based on the calculated generators. And monitoring the progress, basically this section prints the current epoch, batch number, discriminator loss and generator loss of every batches. So in simpler terms, these lines of code basically what it defines, what we want to do here. So imagine the generator as an artist trying to paint a real looking image. The discriminator acts as an art critic judging the paintings real or fake. They take turns learning from the each other. So the discriminator tries to get better at identifying fake images, and the generator tries to create images that fool the discriminator. So by constantly improving each other, they eventually reach a point where the generator can create a very realistic images. So it's a basically self-learning process. So our model doing that. So yeah, that's the real world scenario in real world example of GAN. And yeah, so thank you guys.